What's going on, everyone? I'm back with another cheat engine tutorial. Today I'm going to be using Terraria to show you how to search for time and just cover that whole sort of spectrum of games dealing with time typically. So there are a couple of things that you can safely assume. One being that time is most likely represented in double or float value type. Alright, so that's typically a safe assumption, but in some games timers are a real pain in the ass because it's not that the developers set out to make their timers a pain in the ass. It's more a case of, whatever they're coding the game in and whatever compiler they're using, the way that compiler decides to represent the code of whatever for the timer. So maybe, so the way a compiler typically works is it takes code, like let's say C++, and then it takes whatever you've written in there and it tries to optimize it to make it the most efficient, to run it the most efficient way possible in the processor. And so when that happens, sometimes you'll get all kinds of weird, crazy stuff, like, maybe you're multiplying two values in your code that you've written, but then the compiler sees that multiplication that says, you know what, the CPU is going to be able to run that calculation faster if I change it to adding two integers or something. So if you're doing like 2 times 5 in your code, which would be 10, the CPU might be able to run 5 plus 5 faster. So little things like that. Anyway, all that to say that sometimes with a timer, you might have multiple values that have to do with time. One might be with seconds and another is with minutes. So if you're searching for like increased values or decreased values with what looks like just a 3-digit countdown timer or something, like counting down from 300, it might be so much more going on in the back end than that. And even doing something like a value type all, scan type unknown initial value, even starting with something like that, which that first scan will give you essentially everything related to the game in memory. Even searching for changed and unchanged values after that first scan can yield no results, so you really have to get creative. Anyway, luckily Terraria is not crazy like that at all. So there's a couple of approaches you can take to this. So basically in Terraria you've got time, and time is time. So the sun and the moon go by up above, which you can't see either of them right now. It's getting dark at the moment in the game. But you can either start with a value type all and a scan type for unknown initial value and do first scan, and then come back in the game. Let's try it here. Boom, we've got that. Come back in the game. Now we know that time ran a little bit, so we could say changed value. Well, since we've got the game paused, we know that whatever value time was, since the game is paused, it hasn't changed since our last scan, so we could do unchanged value. And just maybe keep doing that, whittling your results down, right? So you can do this, but this can take a lot of time because typically once you start getting down to maybe like, 50,000 results or something, because you have the same address being represented in different value types, right? Like see this address right here, byte, 2 bytes, 4 bytes, 8 bytes, what is that, single, double, or string, I'm sorry, double, right? Your results get to be a ton. All right, so that's kind of like the safe way. That's the fail safe if you can't find it through maybe a faster method, which is what we're going to try to do here. So like I said, typically timers tend to be float or double value types. So I started with float and that wasn't what it was, so then I tried double and then I found my way to it, but there was still some guesswork being done. So just to spare some time, I'm not going to go through those. All I'm going to do is start with double, and we're going to say unknown initial value. That's how I started it, okay? So First scan, unknown. All right. Now, this is where you want to guess. Is time increasing or is it decreasing? Do you think something's counting up or counting down? It could be either or, so the guesswork begins. Once again, I figured out its increased value until it resets to 0, and then it starts increasing again. So right here, where I'm at in the game, where it's turning into night, there's still enough time left that it's not going to do it just yet, but presumably this counter is going to get up to a certain point where then it resets to 0. So if I keep looking for increased values and I do that when it flips over to 0, the value I'm searching for is going to be lost in that one scan because it will think the value decreased to 0. You see what I mean? So sometimes you just have to really, you might be on the right track, but you provisioned for something wrong just once, you know? So anyway, so I'm going to go increased value, come back in the game, next scan, come back in here, next scan, keep doing that. And you can set up hotkeys so that you don't have to keep clicking back and forth. You know, that's typically what I do. Which, if you don't know how to do that, it's edit settings, hotkeys, and then you set stuff in here. Alright, so back here. Increased value. And the reason I keep clicking back on the game is making sure that it's definitely running through time and not pausing when I click off the window, because I have it set to auto pause. So now, once I've done this enough, I got to this point, around 1800 results. And I'll just start guessing with things. So I don't like to start with these ginormous decimal related values initially. I like to look for something like this. And luckily, this is it. This is time. Alright, so this is one of the first ones that I messed with actually whenever I was doing this. So here's time. Presumably, I didn't know what it was at first, so what I did is I double-clicked it, brought it down, and then I checked to activate it, hopefully locking this value at this. So now I'm back in the game, and you can see this like conflict happening here. All right, and so for those of you who don't know, Cheat Engine doesn't just lock something in memory. It's trying to overwrite the value faster than the game or whatever writes a new value there. Okay, so hang on, let me go in here so I don't have to deal with enemies. Oh, what up, dog? Man, he slayed that fool. All right, anyway, so because there's not a sun or a moon in the air, you can't really see it right now, but you know, another way to influence this is let's just go ahead and set this to like 25,000. Boom. See how the sun moved back to here? And now we've got this locked. So if you look closely enough, you can see how the sun looks like it's kind of like vibrating. And that's this conflict that's happening. Or it's trying to move forward, but it's not. Alright, so this is the first part. We found what's going on with time. And, you know, this is hacky enough, you know. So essentially, if you wanted to freeze time, this is good enough to get the job done. But we want to go farther than that. We want to try to like fast forward time or stop time like legitimately without it looking like this jitteriness here, right? So I'm going to unlock that, and then I'm going to say what writes to this address. So we're looking for the instruction that's writing to this address, that's writing this value to this address. And let's see what we see there. So come back in the game, and boom, there it is. So click here, we go show disassembler, and now we look around in the code. So floating point registers, typically those opcodes start with F, right? So they work, floating point registers are like their own beast. You have to really study just those alone, which I'm still doing personally. But suffice it to say, what we have going on here, this is the instruction we're finding where the value is being stored. We come up here to fadd, and the fadd address, this is an address here, which is the same address that's here, which as it happens is this address where the value is being stored. So we know that there is a value being stored into this memory address, and before that there's something being added with the value that's in the address before it's then stored back into that address. And the way that floating point registers work with something like this is there is a value in a floating point register that's being referenced whenever you do like an fadd. So whatever's in that one floating point register is then being added with whatever value is in this address being referenced. Okay. Well, what could that be? You go up one more and we see an integer being loaded into one of the floating point registers, and it's coming from this address, right? Or that's where it's being stored to. So we've got this 1 here. All right, what is this? Where does this 1 come from? Would this be something related to the speed of time? So presumably what it looks like we're looking at here is 1 is being loaded here. It's being added to whatever the number is that's currently in this address, which we've identified is our address with time in it. And then that value, that new value, is being stored there. All right. So let's see about this. What happens if we change the number that's in this memory address? All right. Well, how can we do that? Let's manually put this address on our list here and see what's sitting there. We know it's 1 because, let me close this, because it's got the value right here as a comment. But let's go add address manually. We're going to go 012E, not W, but E, 56E4, 56E4, and we see a value here of 1. All right. And I'll do something like that when I'm doing this like little bit of studying, FILD, just as a quick frame of reference for what I'm doing here. And we see that the value is 1. Can we change that? Can we change that 1 to anything and have some stuff go crazy here? Let's try changing it to like 200. And then going back here. Nope, it just changed right back to 1. So we can't influence that value right there from this memory address. We can't do that. What we can do is try to find what's writing to that address right there. Okay? So we've already added that address here. Now let's right click here and find what writes to that address. Come back in the game. Excuse me. Escape. Alright, here we go. This instruction. It's moving 1 into this address. Perfect. Let's click to show that in the disassembler. Here we go. Look at this. We can work with this. Alright, sometimes you get little like peripheral information like this over here on the side. Terraria main update sundial. That sounds like something we're looking for, you know. Sorry, I keep coughing in your ear. Got some allergy crap going on right now. Anyway, alright, so let's try to mess with this 1. How can we do that? So I'm going to stop this. Close it. What do I have here? I'm going to stop and close that one. So now we're going to go Tools, Auto Assemble, Template AOB Injection. And we say OK here, and then we call this time. Alright, so when you do an AOB injection like that, I like to bring it up just so I have kind of the basis of what I need to run my script. We're not actually doing a code injection. All we want to try to do is change this byte from 1 to something more than 1, just to see what happens. Right? This is just me screwing around, seeing does this actually influence time at all. You know what I mean? So, bam. Come back over here. Don't need any of that stuff. Don't need this. We're not actually going to be like injecting code, so we don't need to allocate new memory for anything. We don't need any jumps to happen or any of that stuff. We don't need labels. We don't need any of that. We don't need new mem. Alright. We do need to reference the array of bytes that we scanned for, which AOB scan, it calls this time, so we can say time, which also we want to register symbol time. Alright, this allows us to reference this outside of the script, somewhere else in Cheat Engine, and I'll show you what I mean in just a moment. Alright, so here we have time, and again, we're not doing anything with the instructions, so we can get rid of that stuff, and this, and the return, and that. What we want to do is declare a byte. We want to declare something more than 1, so let's do FF. All right. So remember that whenever you're doing stuff in here, you're speaking hex, right? Not decimal. So if you ever want to do decimal, you could do something like int and then put the number that you mean right there. All right. Or let's say your number is 32. You would do that because if you did this, that would be hex 32, which is in decimal something more than 32. All right. So we're going to go declare byte ff, and then when we disable the script, we want to put the byte back that we're changing. And don't worry, I'm going to talk about what all this stuff is. This is our snapshot of code, which is like right here. This little area is right here, so we've still got it to reference. So what we want to do is, because the byte that we want to change is right here, and how do we know that? Well, this section of code outside of the C3 is here. It's just adding that byte in to try to create a more unique array to scan for. We've got this. The C705 represents the move opcode in byte format. So every opcode has a related byte that it's represented as. Okay, so C705 seems to be this move, and then our memory address right here is this section, right? E456-2E01, E456-2E01. The reason why it's reversed has something to do with Indianness. END, end, Indianness. Look that up sometime. All right, and then once we get past that, we've got our value here. All right, so 1, 0, 0, 0, 7 zeros, and that's this. So this 1 is the one that's being moved into this memory address, right? Move into this address, this value. That's the byte representation of this, right? So now that we know that, we're trying to move, instead of 1, we're going to move FF, which is 255. I believe FF is 255. Let me just make sure here. Calc hex FF to dec. Yeah, 255. That's right. Yep. All right. So anyway. All right. So we're that far. So now this being these bytes, we want to modify this one, which we know represents this 1. So what we want to do is when you enable the script, Cheat Engine is going to do this right here. It's going to go array of byte. All right, let's do read and write here. Array of byte. It's going to search for this array right here. Right now it's finding 1 result. All right, and I'll tell you that that's not going to be the case later. Like if you close the game and reopen it, and I'll explain why. But anyway, when you enable an AOB script, it's basically doing this just automatically, right? So once you've done that, it's going to reference this array on the back end. It's going to reference it as time. So it's called time. So now, because we're registering a symbol called time, we can reference time outside of this script somewhere else in Cheat Engine. So let's say we wanted to see this array of bytes really quickly, right, whenever we enable this script. So right now I'm just going to go File, Assign to Current Cheat Table. All right, so we've got our script here. We can call this time script. And now we could say, let's enable it. All right, and we'll go add address manually. If you call it time, and then you say array of bytes, and you say OK, you've got this. This is the representation of those bytes in decimal. We want to change that to show as hexadecimal. Boom. This right here, actually, I completely screwed up. Let's undo that, which screwed something up. And now we want to do this. I screwed up because I didn't change time to the byte offset that we need to change it to. And this is good because I get to show you this. So right now, instead of C705E4, there is a 01 here because I disabled, and when I disabled, it rewrote this byte. So when I enabled it, this byte became FF. When I disabled it, this byte became 0, 1. We need it to be C7. So right now it's 0, 1. So I'm going to say C7 and then C7 just to fix my error here. I'm going to say OK. Let's do this, 0, 1. If you're confused right now, don't worry about it. New scan, first scan, only one result, good. Enable the script. It found it. Okay, now our byte array is good again. Alright, so hopefully that didn't screw things up too much when I come back into the game here. Okay, good, we didn't crash. Alright, so anyway, back to where we were. As you can see, our bytes here, that's the same array that we had here. So let me change this back to what it should be, which was C7. Now we're going to come back here and go FF and then 0, 1. Okay, so this is just a way for you to reference something outside of a script and see like your byte array if you want. Anyway, so now what we want to do is, because this is the byte we want to change, whenever you run your AOB, this time is going to start at this byte. Whatever you've called this is referencing this byte. So we want that byte plus 1, 2, 3, 4, 5, 6. Alright, so our 6th byte. So it would be time plus 6. Time plus 6. Okay, so the script runs, it finds that byte array, it references it as time, and then we register a symbol called time so we can reference that outside of the script for whatever purpose you might want. And then it says, well, okay, I've found this and I've called it time. Now what do you want me to do with it? So we're saying, all right, well, time, which starts at this byte, plus 6 bytes, 3, 4, 5, 6. I want you to declare a byte FF. Declare a byte basically means write this here. Put this here. Alright, so that 1 will become FF. Then when we disable it, it's going to unregister the symbol time and call that memory address whatever it is normally. And then it's going to rewrite whatever value you want there. So it is 1. I'm just putting back what is there now before we enable it. So now we say OK. I'm going to disable the script and re-enable it. Come in the game here and look. Time is flying. Alright, this is typically why I like to fast forward time, because I like to make it rain. Make it rain? What? Alright, so it's raining. Now you could freeze time by doing something like, let's copy the script. Let's paste the script. And we'll call it stop time script. Boom, we come here, we'll delete that because it's not needed. Alright, and you see how this value now has 255 in it? That's our FF. So we know that now in this address is the value that we wanted it to change to. And then through the address of time, which we found, you can see how fast time is flying whenever our script is enabled. But anyway, we want to stop time, so we've copied the script. Alright, so instead of declaring byte FF, let's declare 00 and go OK. Now I'll disable this script and I'll enable the stop time one. And now, whatever time it is right now, you can't see it because it's raining and dark, but if there was a moon here, it wouldn't be moving. And it wouldn't be doing that crazy jittery thing that we saw the sun doing at the beginning. Because we have 0 there. There's no conflict going on. You can see here, time is just nixed. Time is not moving. Cool. Alright, so now that we've got that, you could create all these individual variations of the script, and you know, you could like tie things to hotkeys and do it different ways to just do this array of byte scan, and then, you know, once you enable that script, then you can reference time in other scripts or other things and do whatever stuff you want them to do. Alright, so the last component of this is writing an array of byte script that's going to work for you when you restart the game. Alright, I can tell you now this is not going to work if you close the game and restart it. The reason why is part of this array of byte script is a memory address right here. Alright, this E4562E01, that's going to change. whenever you close the game and reopen it. There's going to be a new address that these values are in that are being referenced. Okay, so what you do to provision for that is you use question marks or asterisks. I'm just going to use question marks for each one of these bytes. So 1, 2, 3, 4. And now what you can do is say, okay, now that I've provisioned for there being something random in this array of bytes, a memory address, let's search for this and see what else might pop up here. So you go new scan, you know, you've got your array of byte stuff selected. We'll paste it here and go first scan. 44 results. Alright, so what do you need to do? You can start adding bytes onto the end to create a more unique array, or add bytes to the beginning. If you start adding bytes in front of this, you're going to have to start provisioning for it with your time offset here. And don't forget, things work in hex here, not decimal. So if your offset is like 17 bytes away, that's going to be like, what, 11 in decimal or something like that, right? Let's just say it's 15 bytes away. If it's 15 bytes away, that's going to be F. Okay, so 0 through 9, A through F, that's 15. And then 10 is 16, 11 is 17, etc. All right, so anyway, that's if you start adding bytes onto the beginning. But if you want to start adding bytes onto the end, okay, what we can do is, since this can be a value that changes, I think maybe there might be like some potions in here that make time speed up a little bit or something. I don't know. If that's the case, I imagine this byte might change. So I'll do questions for that one. And then C3 is here. You can start picking up from here. Add, see how this add is like 0, 0, and then you've got FC, but then up here, let's see, there's another add around here that maybe that was just in another version, but I had adds that weren't 0, 0. They were like 0, 4 and then something else. So if it's an add or something like that, I like to use question marks for those. So we've got the C3, which is a return, which is typically the same. We'll keep that there. Then for this 0, 0 FC, I'm going to do question marks for that. And then for this exchange, this 8, 7, typically we could roll with that 8, 7. And then I'll do question marks for these next two. And then for these adds, I might do question marks. But right now I'm just going to see what kind of results do I get if I do a new scan for the one I've built up currently. And we've got one result. So now this might be a good enough array. We're not going to know until we close the game and reopen it. All right, and you might find that when you try to run that script with this, it might not run, which means one of these bytes changed. Like this 8, 7 might be 8, 4 or something like that. So then you would need to change this 8, 7 to question marks, and then start adding bytes onto the beginning or the end accordingly around your code, or around your string rather. All right, and eventually you'll end up with a unique array that will work every time you close the game and reopen it and you've got your script. All right, so that's how you build out a script like that. So anyway, that's essentially how you do it. This is, speaking of script, this is unscripted. I just decided to hop on and do this. I'm actually leaving town here in just a little bit, and I wanted to get something up. I'm going to be gone for like 4 days, but anyway. Feel free to ask some questions if you have some questions. I recommend, though, going back and watching my other videos, because I've most likely answered the question in another one of those videos. All right. So here you've kind of learned how to provision for timers, sort of, you know, and you've got a little more of an idea of how stuff works whenever a game is like being compiled, and why you might be looking for some different sort of stuff here in the code. Also, whenever you go to do like an AOB injection or whatever, you don't have to be injecting code. You could just change a byte. You know, you can search for the array of bytes and then not allocate new memory and have anything jump anywhere. Just declare a new byte in place of another byte. You know what I mean? So, yeah. Give me a thumbs up If you enjoyed this video, let me know what else you might want to see, and I'll try to go over that maybe in a future video soon. And don't forget to subscribe if you're not yet. Lastly, check out my Cheat Engine tutorial series if you haven't done that yet. I've got tons of videos for that, and I promise you'll learn a lot. So anyway, thanks so much for watching, and I will see you guys in the next video. Take care.